All right. So you're sort of okay at simplifying expressions that involve complex numbers. But can you solve equations with complex numbers? And the answer is actually yes. The way we do this is it's basically solving regular equations that contain real numbers, but you have an extra step involved. When we're dealing with complex numbers, how many different components make up the complex number? The real part and the imaginary. So how many do we have, Foreman?
Two.
Two components make up our complex number. And because of that, that means that we're going to have to solve the equation in two steps. On the left, we have real, complex. On the right, we have however the question was given to us. So what we're going to do is step one, we arrange the question such that it's in Cartesian form. The real part plus the imaginary part. So x and minus 2 are real, plus the imaginary part, 2i plus 2iy. So that's going to be 2 plus 2y I. So all of a sudden you've got real, imaginary, real, imaginary. Now the next step is where the real magic happens. We build an equation based on the real components. This part's real, that part's real. So therefore, 3 equals x take 2. So that's one equation. To solve our equation, we move our unknowns to the left, our knowns to the right. So we're going to get x equals 5. Does that make sense? Now, let's go for the imaginary magic. We build an equation based on our imaginary components. The imaginary part on the left is 4. The imaginary component on the right is 2 plus 2y. So therefore, if we solve for y, we're going to get 2y on the left, 2 on the right, divide by the coefficient, y results in a value of 1. So therefore, our answers for this are x equals 5, y equals 1. Very cool, considering that this is the first time you've had an equation containing two unknowns and yet you're still able to solve the equation. Usually it's one equation per every unknown to be able to solve a system of equations. Does this make sense, guys? So it's like regular solving equations, except you split it in terms of real component, imaginary component. Now for the second one, we're going to have minus 4 plus 5i equals negative x minus 1 plus ix plus iy. Have a think. How will we solve this? Don't even. You got algebra to do.
I did do it.
Keep doing it.
Yes, I am. I did the first part.
Okay, look at it until it gets intimidated.
Just stare at it.
Don't stare at it, look at it with a fierce look so it knows you're serious. That's it. Okay, so what are we going to do to start off here? What do we need to group?
Real and imaginary.
Real and imaginary. So I like to group them with brackets or braces, brackets or parentheses, it doesn't matter. It just helps you know what the real component is and what the imaginary component is. Next, you don't have to write it out, but I like to keep my working out tidy. The real component's minus 4. Oh, if you need to go, you just go. Yep, see ya. Then solve for x. The unknown belongs on the right, the knowns below on the, sorry, unknowns belong on the left, knowns belong on the right. So we're going to get minus 1 plus 4, which is 3. Do we agree? Okay. Now, imaginary. It's going to be, help me out please, Alex. How are we going to start this imaginary equation?
5i equals ix plus 5i.
Remember, we don't need to put the i's in there.
Just x plus 1.
The coefficient on the I is your imaginary part. Now, do we know what x is?
Yes.
Yeah. So we go simultaneous, but x is known to be 3. Comprende? Alright, now there's one more situation. Is this enough, or do we want to see the final case that you could get? Hands up if you want to see one more. Hands up if you've got enough information for one lesson. Okay. Alright. We will cramp ourselves in the corner. Alright. You would have seen something similar to this when you did your polynomials topic. So we have 9 minus 12i equals y squared minus xy squared. Are they already grouped in Cartesian form? Yeah, because this example isn't to show what we've already done, it's to show something new. So our real component is going to be what, please, Levi?
Yx doesn't have an I on it.
9 equals
Y squared.
y squared. Hence our y is going to be what? Plus or minus root 9, so plus or minus 3. What about our imaginary?
Negative 12 equals negative squared. Or times 1.
Okay. Do we have a known value for y in this case, please, Akifa?
Sorry.
Do we have a known value for y? That's okay. Do we know what y is?
Yes.
Possibly. We know 2 potential answers for y, plus or minus. So we can say, but y equals plus or minus 3. Now here's the thing. What do? We've got 2 potential values we can substitute in here. Which one do we choose? Both. It's like going to the Gelatissimo and you get 2 scoops, 1 of each flavour. For our first serving, we're going to go minus 12 equals negative x, and then it's going to be plus 3. And then for our second scooping, we're going to go minus 12 equals minus x times negative 3. And then we just solve for both. So we are in fact going to get multiple answers. For the first one, we can do it straight away. Negative, negative, positive. 12 divided by 3 is 4, so x has to be 4. For this one over here, it's again going to be negative, then 2 negatives over here, so one's negative, one's positive, so x is going to be negative 4. So we actually have 2 answers containing 4 numbers. X is 4 and y is equal to 3, or x is equal to negative 4 and y is going to be equal to negative 3. So some of these equations will have multiple answers. Is that okay? Yes? Question, Maya?
No, I actually figured it out.
Okay. So this is probably going to be the most challenging stuff that you work on for homework over the weekend. If you're stuck on it, don't stress out over it. Bring it to class and we can work through some of it together. Seem okay?
Yep.
All right. So